Welcome everyone. In this video we're going to go over one exam question from 13.2. So this is problem number 13 here. And this is, let's see, fall 2017 is when this showed up. We would like to figure out maybe which of the following satisfies that its derivative is equal to 2t, 3, negative sine t. And if you plugged in 0, you would get out 1, 2, 3. Okay, so because this is a multiple choice question, you could go through and for each one of these options, you could take the derivative of it and you could plug in 0 and see if it satisfies those two things. Or, right, we could actually use kind of assuming that it's a standard response question, right, we could try to derive one of these answers. So I'm going to go ahead and do that case. So I'm going to go and do kind of the more general case, and not assuming that this is a multiple choice question. And so I'm going to start with that the derivative is 2t, 3, negative sine t, and I want to figure out r of t. So I'm going to integrate, right? So I'm going to integrate this vector, 2t, 3, and negative sine t. And so when I integrate this, so again, this was something that came up in 13.2, right? You just integrate each component. So I'm going to go ahead, when I integrate 2t, I get t squared. When I integrate 3, I get 3t. And when I integrate negative sine, I get positive cosine. Because again, the derivative of cosine would be negative sine. But we know when we integrate, right, we get a constant of integration. And the big thing here in Calc 3, right, because this is a vector, a constant vector, since we're doing vector integration, right? So it has components, maybe like a C1, a C2, and a C3. So this is a constant vector. And so that C1, C2, C3, that's going to help me to guarantee that when I plug in 0, I should get out the vector 1, 2, 3. So let's go ahead and check. So when I plug in 0, so if I plugged in 0 into t squared, I would get 0. If I plugged in 0 into 3t, I'd get 0. If I plugged in 0 into cosine of t, I'd get 1. And I want to get out the vector 1, 2, 3. And the question is, what do the c values then have to be, c1, c2, and c3, to make that happen? So this is a little bit of a game. 0 plus what equals 1? Well, that should be 1. 0 plus what equals 2? Well, that should be 2. 1 plus what equals 3? Well, it should be 2 again, right? Because 1 plus 2 equals 3. And so therefore my constant should be 1, 2, 2. All right. So if I go ahead and, kind of plug these in, I would have, let's see, t squared, comma 3t, comma cosine of t, plus 1, 2, 2. And let's see which of my answers looks like that. So here I have t squared plus 3t plus cosine of t, but I don't have the 1, 2, 2, so that doesn't look right. Here, well, it looks like we actually combine these things, right? So if I combine these two vectors, let's see, I'd have t squared plus 1. That looks good. I'd have 3t plus 2. That looks good. But in my last coordinate, I have cosine of t plus 3. And I need cosine of t plus 2. So, okay, sadly not B. How about C? Okay, negative cosine. That's not right. How about D? This is good so far, yes. And aha, cosine of t plus 2. So D is the correct answer here. All right, so again, the answer is D. That is one example from 13.2. Remember 13.2 we had vector derivatives and vector integrals, all that good stuff. So that's how we can apply it to a problem that we've seen on the exam. All right, that's it for this video. I'll see you guys next time.